All right, guys, this is 413 for Algebra 2, and today we're going to be talking about systems of equations today. So to start, I'm going to pull this up. All right, so I want you guys to go ahead and pause and then solve A, B, C, and D as systems for me. And then come back here and I will go through those. All right, so starting off here. Oops, wrong one. There we go. All right, so we're going to have y equals negative 3x plus 5 and y equals negative 3x minus 1. Now, when you first look at this, you should see, hey, these are two lines with the exact same slope. I have parallel lines. They have different y-intercepts, so they're going to be having no solution because they never intersect. I'm still going to solve it out, though, so that we see what happens algebraically when we have this whole no solution case. So I would substitute all this in for the y here, and I get negative 3x minus 1 equals negative 3x plus 5. If I add 3x to both sides, those both cancel out, and I get negative 1 equals 5, which is a false statement. If I get a false statement like this, which is never true, it means there's no solution, because this can never work. So I have no solutions. Just like that. All right, then on B, we have y equals 1/2 x squared plus 1, and we have y equals 2x minus 1. So probably want to do substitution here again. Let's plug all this in for the y over here. So I would get 2x minus 1 equals 1/2 x squared plus 1. So I have an x squared and I have an x. I have a quadratic. Let's get everything on one side and then equal to 0. So I'll have 0 is equal to 1/2 x squared minus 2x. And that would be then a plus 2 because 1 and plus 1. So then I have that fraction. Now, one of the strategies we talked about earlier was, hey, I can get rid of fractions by multiplying by that common denominator. I only have one denominator, so it's really, really easy. It's just going to be 2. Multiply everything on both sides by 2. Well, 0 times 2 is pretty easy. It's still 0. That's part of why we like having that 0 there. Equals now x squared minus 4x plus 4. Well, let's solve it out by factoring. I would get x minus 2 and x minus 2. So I got the same answer twice, which is both going to be 2. So x equals 2. Awesome. Now I have to find the y which corresponds with that particular x. So to do that, take that 2, plug it in. 2 times 2 is 4. 4 minus 1 is 3. So my y value is 3. Now I'm solving a system, so I want to write my answer as an ordered pair, not as two separate things there. So I get the ordered pair 2, 3. That matters a whole lot more when you start to have more than one answer, but it's a good habit to kind of be in for any of these. All right. So moving down to part C. So this is where we're going to start to get a little bit trickier. So I have y squared equals x, and I have y equals x minus 2. So people get really hung up on, well, if I want to plug this y in, I need this to be just y, not y to the second. And they try and square root, and they have y is equal to plus or minus root of x. This makes it really, really nasty, and you have to undo that very, very shortly after. So what we just do instead is to say, well, take this, plug it into the y, and we have x minus 2 squared equals x. So now I can go through and solve it out. Multiply this through. I get x squared minus 4x plus 4 equals x. Subtract that x over, and I get x squared minus 5x plus 4 equals 0. Because I know that I have to equal 0 because I have x to the seconds and x to the first. So now I can factor it. And I get what multiplies before as to be negative 5. That's going to be negative 4 and negative 1. So then my answers are both positive 4 and positive 1 for my x's. Now to find the y's which correspond. Take this, plug it in. I get 4 minus 2 is 2, so that's going to be the point 4, 2 as an ordered pair. Plug in 1. 1 minus 2 is going to be negative 1, so that's 1. Negative 1 is my other ordered pair. And there we go, both of my solutions. All right. And then last one here, we have 4x minus 2y equals 10. And then we have y equals 2x minus 5. So I could try and sub this in for the y, or I could try and move this over it and then do the addition method. I'm going to plug all this into the y. That seems like the easier route here. So I'm going to do that. I have 4x minus 2 times 2x minus 5 in parentheses equals 10. So this becomes 4x still. Negative 2 times this is negative 4x. And then plus 10 equals 10. Those 4x's are going to cancel. I get 10 is 10. Well, that's a true statement. So this is going to be an identity or have infinitely many solutions, or it is all real numbers. However you kind of prefer saying that, they all kind of mean the same thing, just in a different context. All right, no big deal. So hopping back over here, what I want you guys to do now is go ahead and try number 37. So start off by graphing it on Desmos, see how many answers it should have and where they are. Then try and solve it algebraically. Go ahead and give that one a go for me. All right, so let's go ahead and solve this one out. So this one, there's two options which you can go with. One is going to be drastically easier than the other. So if you got stuck, that's likely what happened. And then we have y equals x squared minus 13. So if I try and say, well, let's just plug all of this in for the y here, right? What I get is x squared plus x squared minus 13 squared equals 25. Right? Now doing this, I would then have to FOIL this out, and I would get x squared plus x to the fourth minus 26x squared plus 169 equals 25. Combine some of my terms, I get x to the fourth minus 25x squared plus 144 equals 0, right? Which is solvable, but it's really nasty because now we have x to the fourth power, right? And as a class, we really haven't learned how to deal with that yet. We will in the future, but just not quite yet. The other option we could take is saying, well, let's get this x to the second by itself. That would just be x squared equals y plus 13, if I add that 13 over to the other side. Well, now I can replace any x to the seconds with this. Well, here's an x to the second right there. So I would get y plus 13 plus y squared equals 25. Well, this is going to be way easier because there's no fourth powers, so I can do this a lot easier. So let's try this one out. So I'm going to get everything on one side. Y squared plus y minus 12 equals 0. Then I can factor it and get x plus 4, x minus 3 equals 0. So then my y equals negative 4 and positive 3. Awesome, I got two answers for y there. Now, what are the x's which go with these particular y's? So take this y, and let's plug it into either one of these. It's probably going to be easier to put it onto the bottom one here. So if I do that, I would have negative 4 equals x squared minus 13. Add 13, and I'm going to get 9 equals x squared. Square root both sides, and I get x equals plus or minus 3. Doing the other one, I would get plug in 3 equals x squared minus 13. Add 13 to both sides, I'm going to get 16 equals x squared. So that's going to be x is equal to plus or minus 4. Now thus, I can't just leave my answers as, hey, this and this. I have to have these paired up, because if I'm solving a system and I have more than one answer, I need to have them as ordered pairs. It's good to always have them as ordered pairs, but you have to have them as ordered pairs if you have more than one solution here. So when y is negative 4, x is 3 or negative 3. So that is the points 3, negative 4, and negative 3, negative 4. Over here, when y was 3, I got x is 4 and negative 4. So that'd be the point 4, 3, and the point negative 4, 3. And those would be my 4 solutions to that particular problem. All right, so let's hop back over here, and we'll skip that one, and we'll just go straight on to this. So with that, that is it for 4.1.3, and I will talk to you guys next time.